Hello guys, I want to welcome you if it's first time coming to my channel. Today I'm gonna show you Newton's first law of motion. Newton's first law of motion. Newton's first law, guys. State or define Newton's first law. What do you remember about Newton's first law, guys? What is it that you remember? Can you state the Newton's first law for me? Write it down there at the comment section. Write Newton's first law of motion. I won't write it down. Write it down on the comment section, guys. I want to check if you understand what I'm talking about here. If you don't know, just say you don't know. Okay, guys, I'm gonna say it for those people who don't know it. Newton's first law state that an object will continue in a state of rest or continue moving with a constant velocity unless an unbalanced force act upon it. That's Newton's first law, guys. Simply say it simply state that an object will remain or continue on its state of motion, which is constant velocity, unless an external force act upon that object. Then that object can move or can stop. If we have a box, like this on the surface of the ground, Newton's first law states that if you push this box along this surface, it will move, because this box was at rest. If this box was at rest, the only thing that can move this box is when you apply a force to this box. That force is called an external force or unbalanced force. You understand? So again, if this box is moving, maybe let's say this surface is ice, it's ice, and you push this box along the surface of ice, this box will slide on the surface of that ice, and it won't stop until friction acts upon that box. This box can be stopped by friction, but if there were no friction available, if the surface didn't have a friction, this box would slide forever, and it will slide until it won't even come to rest, because of there is no friction. You understand? It will act like we are on our galaxy, at the space, when you are at the space and you shoot a gun, that bullet will fly through the space forever and ever. It won't even come to rest because there is no friction on the space. You understand? Yeah. So guys, I will make few examples. Before I can make a few examples, I'm saying this box, when it moves with a constant velocity, it means there is no force acting on it, or if it's on rest, there is no force acting on it. So when this box moves with the constant velocity, the condition of this box is that the sum of the forces acting on this box is equal to 0, or I can say F net. F net is the sum of the forces that acts on this object, is equal to 0. This is when the object is moving with the constant velocity, and when it's at rest, when it's on stationary. So when it's on stationary, the sum of the forces is also equal to 0, and F net is also equal to 0, guys. So it means this box is in equilibrium. When the net force is equal to 0, this object is in equilibrium. So I'm gonna make an example. Before that, I want you to understand that in order for you to answer mechanics or forces, this kind of question, you need to know how to tackle this kind of problems. So I can say to this object, I can say it has a mass of 8 kg, né? And then and then for an example, maybe I can say, can you draw it's on rest, it's at rest, it's not moving. Can you draw a body diagram showing forces acting on this object when it's at rest? So body diagram, you will just make a dot here like this, and you have to represent all the forces that act on this object when it's at rest. So when it's at rest, it's not moving. The only forces that act on this box, it's weight, because it has mass, then it has to have weight. It has weight, and then there is also what we call a normal force. Normal force is at the right angle to the contact surface, meaning it will go up like this. This is normal force, and this is our weight, Fg, or weight. This is our normal force. So obviously our body diagram will be like this. This is Fg, this is normal force. You see, we have a weight, we have a normal force, so they can 78.4 is our Fg. So now they want normal force, remember. So now we're talking about normal force that is opposite our Fg. So remember, this is at rest. So when it's at rest, all the forces, the sum of the forces is equals to 0. The sum of the vertical force and the sum of the horizontal forces. So now, if you want normal force, so the sum of this is 0 because it's at rest, it's in equilibrium. So we have 78.4 plus normal force. They are the same because it's at rest, and then they're always the same, guys. They're always the same, but they act on a different they act on in a different direction, but the magnitude of normal force and weight will be the same. In this case, this is how you calculate normal force. I think you understand what I'm saying here. I think you get what I'm saying here. So there is no friction because it's not moving, it's at rest or it's moving with a constant velocity. So I will make another example. They say they have a crate here. They have a crate here on a rough surface. They say Carol is pushing this crate. Carol is pushing this crate. He's pushing this crate this side to our right hand side, and they say V is constant. So I will read the statement. The Carol is pushing a box to the right at a constant velocity on a rough path as shown in the diagram. She applies a horizontal force of how much? We don't know. There is the horizontal force she applied. So is the box in equilibrium? They're asking if the box is in equilibrium. They say Carol is pushing this box at, this is force of Carol. Carol is pushing this box at constant velocity. Remember here, constant velocity, equilibrium. When F net or the sum of the forces are 0, then it means this box is at equilibrium. So now it's pushing this with a constant velocity. They're asking if this box is in equilibrium or what. We will say it's in equilibrium. Yes, this is our first answer. We will say yes, it's in equilibrium. So the next the next question says, state whether each mathematical statement is true or false for this situation. They say the sum of the forces is equals to 0. The sum of the forces is not equals to 0. The sum of the vertical forces is equals to 0, and the sum of the horizontal forces is equals to 0. What is true? This is question 1. Question 2, it has 4 questions. So state whether each mathematical statement is true or false. They say, number 1, this box, the sum of the forces acting on this box is equals to 0 or what? They say the sum of the forces is equal to 0. So is it true or false? I mean, this it's not equal to 0. The sum of the vertical, sum of the horizontal. Yeah. So is it true that the sum of the forces is equal to 0 here now? That's what they're asking. Is it true? Yes, it's true. Because it's moving with a constant velocity. When something is moving with constant velocity, the sum of the forces acting on that object is 0. So they're asking if the sum of the forces is not equal to 0 or what? This is false. Because it's equal to 0. The right one is this one. So they're asking if the sum of the forces acting on a vertical, the sum of the vertical forces is 0. Yes. Here the sum of the horizontal forces is 0. Yes. So now they're asking, give reasons for your answers in B. Reason is because this object is in equilibrium. An object is in equilibrium. The object is in equilibrium. D. Draw a force diagram of the box. Draw a force diagram of this box. We only have Carol force acting on this body. We only have Carol force acting on this body, guys. We only have Carol acting on this body. Remember, there is also weight, there is also normal force. Normal force is acting in opposite direction to our weight, and this is our weight. Forces here, it means it's gonna. Okay, let us draw a diagram force. This is our diagram force. This is the body, is the box, and Carol's force is this one. F Carol, and we have weight, we have normal force, we also gonna have frictional force. This is our body diagram. This is our body diagram, guys. Remember, frictional force is always there, because it always resists motion. When something is moving, a frictional force will be there because it wants to stop that object from moving. So this is our diagram force. So now the So they say supply the missing force in the equation. They gave us this equation. F Carol plus, and this is the missing force, and they say it's equals to 0. What force can we add to this and give us 0? This will be forces acting on the horizontal forces, because on the horizontal plane, because you see Carol is acting parallel to the surface, he's pushing this box, then it means frictional force will be here, acting in opposite direction towards Carol's force. So it means here we're gonna put Fk, which is frictional force, kinetic friction, but it's acting in an opposite direction. You understand? So this is all the answers, guys. We have answered all the questions that they asked. So I hope you heard me, guys. I hope you heard me. If you didn't hear me, just holler me and say, like, tell me where you didn't understand, and if you didn't understand the whole thing, and I can repeat this this topic, I can repeat this session, but with different example, of course. Thank you for watching this session, guys. Bye bye, guys. Subscribe and like and follow the page. If you on YouTube, subscribe, guys. Thank you so much. Bye bye.